For today, let's look at this interesting problem. It involves various ideas, including invariant and inverse function. Here is the question. We are asked to solve the square of x squared minus 3x minus 5 minus 3 of x squared minus 3x minus 5 minus 5 equal x. Please give it a try before you look at the answer. By observation, the expression x squared minus 3x minus 5 appear twice. So we may let fx equals to x squared minus 3x minus 5. Observe that the original equation implies that fx squared minus 3fx minus 5 equal x. And using the definition of fx equals to x squared minus 3x minus 5, the left-hand side of the equation can be written as f of fx equal x. We'll provide two different methods to solve this question. Method number one, if fx equals x, then f of fx is equal to f of x and therefore equals to x. It means that fx equals to x is a solution for this equation. Since fx equals to x, and we have x squared minus 3x minus 5 equal x. So x squared minus 4x minus 5 equals 0. Factorize the expression in the left-hand side. We obtain x minus 5, x plus 1 equals 0, and this means that x equals to 5 or x equals negative 1. Of course, the answer is based on the assumption if fx equals x. So we'll go to the next case. If fx not equals to x, then what is fx? So one tedious way of doing this is we'll explain the expression of the left-hand side from the given equation. So we obtain x power 4 minus 6x power 3 minus 4x squared plus 38x plus 35 equals 0. You may verify this by your own. Since we know that fx equals to x is one possible solution, which means that x squared minus 4x minus 5 is a factor. Using this information, we can easily obtain the other factor. So for the other factor, it must be a quadratic expression with leading coefficient 1 and the constant negative 7, so that the multiplication of negative 5 and negative 7 give us 35. So we just need to focus on the coefficient of x in this vector. In order to do that, we will focus on the term x in the expression. So the term in x can be obtained by the following method. And hence, using a bit of calculation, we know that the missing term in x is actually negative 2x. And we can verify this by looking at the term in x squared. After all the checking, if fx not equals to x, then x squared minus 2x minus 7 equals 0. By completing the square, x minus 1 squared equals 8, and therefore x equals 1 plus minus 2 square root 2. This is the end of the method 1. The working is a bit tedious, but it works. Now let's look at method 2. We let y equals to fx equals to x squared minus 3x minus 5. Then from the previous result, f of fx equals to x implies that f of y equals x. From the definition of fx, fy equals to y squared minus 3y minus 5. So this equation gives us y squared minus 3y minus 5 equals x. Based on these two equations, we obtain y equals to x squared minus 3x minus 5 and x equals to y squared minus 3y minus 5. We may label these two equations as equation 1 and equation 2. Now consider equation 1 minus equation 2. From the left-hand side, we have y minus x. From the right-hand side, it is x squared minus y squared minus 3 of x minus y. We can factorize x squared minus y squared as x minus y, x plus y. From the right-hand side, we obtain x minus y times x plus y minus 3. So we consider two cases where case 1 is y equals x. Note that in this case, the left-hand side equals to 0 equals to the right-hand side. This means that y equals to x is a solution. And therefore, x squared minus 3x minus 5 equals x. Which means that x squared minus 4x minus 5 equals 0. Factorize it, x minus 5, x plus 1 equals 0. And we obtain the answer x equals to 5 or x equals negative 1. So for case 2, y not equals to x. Therefore, we can cancel both sides of the equation by x minus y. So from left-hand side, we obtain negative 1. And from right-hand side, we obtain x plus y minus 3. This means that y equals to minus x plus 2. And therefore, x squared minus 3x minus 5 equals negative x plus 2. Which means that x squared minus 2x minus 7 equals 0. By computing the square, we obtain x minus 1 squared equals 8. And finally, x equals to 1 plus minus 2 square root of 2. And we can combine the method 1 and method 2 as shown. Both of the methods give us exactly the same answer, and the answer are x equals to 5 or negative 1 or 1 plus minus 2 square root 2. Now, let us look at the sketch of the graph of these two equations, y equals to fx and x equals to fy. Both of them are quadratic expression, so these are the graphs that we can have. And in this case, we have 4 intersection points. What's interesting about this is there will be a unit circle pass through these 4 intersection points. This is true for all y equals to ax squared plus bx plus c. That's all for today's lesson. I'll see you again next time. Bye-bye.